Throughout my career, I worked on medical devices, mainly therapeutics and implants. And I joined this company because I believe a tremendous possibility and opportunity here. The company is LacriScience. It's a privately held company, mainly funded by the founders and angels. And we develop a platform technology, innovative one, for diagnosis of point of care. We can use the same device for multiple applications. The principles involve traditional SPR technology, SPR with antibodies and SPR with DNA. The principal operation here is an SPR, which is surface plasmon resonance. When we shine light onto a prism and behind it we have a coating of gold, we have a droplet behind it, the reflection angle at a specific point get absorption, and you see minimum there on the graph. That minimum depends on the refractive index of the tear, and when the refractive index changes, that minimum changes in position. We develop a versatile handheld device with miniaturized electronics and optics and software that can be attached to a disposable prism with a special proprietary coating. Everybody talks about dry eye, and it's a hot subject now. And if you look at the distribution of a normal eye, you'll see it in blue, and the people with dry eye, it's in the green, and there is a difference in the mean value of the osmolarity. So attempts were made to measure osmolarity to determine the degree of dry eye. In the past, we reported the ability of the instrument to measure osmolarity, and here is the linear relationship between salt and osmolarity and the refractive index. But if you look at the tear has also a linear relationship with this steeper curve, and therefore we can have a larger range on our detector and increased accuracy. Recently, we focused our energy in improving the quality of the sensor and the angles and optics, and the same variation from sensor to sensor as far as docking it to the instrument. We also work on accuracy, and our goal is to achieve about 2 milliosmol accuracy, and we're very close to that. But measuring osmolarity is probably not enough for dry eye. We felt that measuring inflammation will be a major benefit to the clinician as far as taking care of the patient and monitoring the situation. And we developed a technique where you coat the gold with a special antibody specific to the MMP9, which is a marker of inflammation. Two graphs, the results of the shift of the SPR. And at 300 nanogram, it shifts about after 12 seconds, and with 5 nanogram, it shifts in less than 8 seconds, but not a different value. Therefore, we'll be able to measure the level of MMP9 in the tear, which is very useful. Lately, the company acquired exclusive license for technological lysate. It's a proprietary chamber where you put your sample, either urine, blood, saliva, or tear, expose it to microwave for about 30 seconds, and you break the organism parts to the DNA fragments, and then we can use our pen to measure the result. Our first attempt was to measure the cholera bacteria, and we coated it with anchored DNA onto the gold, and you could see very clearly a shift in SPR. Therefore, you know that you've achieved the detection of the cholera organism. In cornea, it's also important to consider herpes. So we've done some tests for feline herpes to be able to see if we can detect that. And here we also coated the gold with anchored DNA specific for the feline herpes, and you can see a shift into the SPR, and you'll be able to detect it within a few seconds. This technology, as I said, it's a platform, and it can be expanded beyond ophthalmology. And here is an example. We looked into urology markets where we're going to measure the E. coli. This was about 5,000 CFU of E. coli, and you could see again a shift in the SPR. did a financial model using those type of products, and we anticipate after launch of the product, within 5 years, we'll probably achieve $73 million of revenue. And currently, the company is seeking either a corporate partner and financial investors for minimum about $5 million. Thank you.